Okay, good morning, everyone. The lecture this morning is going to be fairly brief, I believe, but it's on a fairly important topic that a lot of iOS developers don't understand until they basically develop for the platform for a year or maybe even two. And that is just the different parts that go into an Xcode project and how they work together. Usually you don't have to care about that too much in the beginning, but as you start adding libraries and building more complex projects, you usually should know about these things, but it's not super easy to get an overview, so I hope this lecture will give you an idea of what workspaces are, projects, targets, schemes, all such kind of things that you might hear about in the next couple of months. If you have any questions around that at any point, then let me know. So I'm going to start talking about projects and workspaces, then targets, schemes, build settings. We're also going to talk about code signing, which is kind of an annoying thing, and most of you will basically trip over it when you try to submit your first app. And then at the end about the entitlements, plist, and the Info.plist. So none of this stuff is incredibly exciting by its own, but if you actually get stuck in any of these steps, then this lecture should be helpful in resolving issues. So I think it's pretty valuable. So if you start an Xcode project and you actually build a little bit more complex project, then it might look like this. On the top, you might have a workspace. A workspace is a collection of different individual projects. You're always going to have at least one project that is going to represent your app, but you might also have other projects which can be libraries or frameworks that you want to use. Inside of each of these projects, you have what we call targets. And I'm going to talk about each of these components a little bit in more detail, but targets are essentially a definition of how you build a product out of your project. So a potential product could be the app that you install on a phone. So the target would describe how to take the individual parts of the project and then build an app out of it. So that's a high-level overview of some of the different components that go into building an iOS app. What are projects? Projects are essentially just a collection of source code and resources that you need to build any kind of target, and they're typically structured into groups. So these folders you see in Xcode are not actual file system folders, but they're called groups, and they allow you to organize your resources. The projects also are a collection of different targets. So you can not only have one target, which would, for example, be the app that you put onto the device, but you might have different targets, for example, one that runs tests or one that generates documentation. Or in some cases, you also have multiple targets for the same app if you have a free and a paid version of your app. Then you would take the same source code, but you'd have two different targets, one that is built for the free app, one that is built for the paid app, and that they're slightly different. Additionally, you have build settings. Going to talk about that a little bit more too. You have build settings essentially on the project level and on a target level, and these build settings define different rules about how your project is going to be compiled into the target. So I talked about targets quite a lot. You can find targets inside of the project navigator here on the left side. On the top level, you see a project, and below that, you see targets. By default, you typically have 3 targets in total. The one is the actual app that is going to be built onto the device. And then there are 2 different test targets. We're going to talk about automated testing, but essentially these test targets are used for that process. That means they run your app and they run tests similar to these tests that you have now built for your API server. And these are bundled into separate targets. Each of these targets defines how a product is built. So the app target will define how the binary is built that lands on your phone. The test target will describe how the tests are built and how the tests are executed. These targets can override the build settings of the project. So the project will have some settings, and that will, for example, define where the frameworks are linked. That's a specific folder. And then your target can come in and override these settings and define specific ones for the tests or specific ones that are only valid for your app. We won't really dive into the details of that, but it's useful to understand that you can have settings that are different per target if you actually run into a situation where you need to define multiple ones. Another topic that you might have heard about are schemes. You can find them when you click into the top bar. We have the name of the app and the device that you're running on. Then you can select a scheme. And a lot of your apps will come with multiple schemes. You can select them from a list over here, and you can edit them in a view that looks like this. A scheme is basically a collection of targets that you build with different configurations and the collections of tests that you might execute when building these. So most likely you won't have to touch the schemes really, but the schemes allow you to define how your app is built onto the device and how this runs. So a scheme is a combination of a target and your project, and basically the way of how the project is executed. So for example, on which device it runs and which launch flags you have. So what are build settings? Build settings is a long list that you can see when you select a target or a project and you go to the build settings tab. Essentially, it allows you to define anything from the target SDK, for example, will this be built with iOS 7, will it be built with iOS 8, to like the deployment targets that defines on which types of devices it can run. And there are a whole bunch of settings. It's actually kind of interesting to look over them, and you'll have to deal with them in many cases when you have build errors. So understanding some of these build settings is pretty important. Yeah.
Can you talk a bit on the different architectures and why in most of the options they have debug and release and what are the differences?
Yeah. So the question was, can I talk about the different architectures and why they have debug and release settings? So I think actually for architectures we don't have that particularly, but in general architectures define on which processor, on which architecture can your app run. One of them, for example, is ARM64, which is typically the simulator. So the simulator has a different architecture because it runs on your Mac than actually running on a phone because there are different processors. Then there are different types of processors on the phone. There is ARM7, ARMv7S and ARM7. These are the newer phones. There are even ARM6 ones that go like to the iPhone 4, I believe. So essentially, they're different architectures, and they have slightly different feature sets. Usually, you're not concerned with that too much, but it basically allows you to exclude certain device types. For example, if you use a library that only runs on ARM7 and it doesn't run on ARM6, then you can exclude ARM6 here by not including it in this list. And if you have ARM6 in there, then you have to basically build two versions of the library, one that runs on the older architecture and one that runs on the newer. I'm not 100% which one is mapped to which device type, but essentially different processors for different devices. Then the debug and release settings are more relevant for most of the other build settings. Essentially, you can imagine if you test your app, there might be some settings that you want to activate in debug builds when they run on the simulator, when you want to test them. But then you don't want these build settings to be activated for release builds. Some of them are, for example, how your app is optimized. So the compiler makes some optimizations, and in debug mode, it leaves out all of these optimizations so that you can have breakpoints, you can easily analyze your code. Whereas in release mode, it will optimize your code as much as possible, but that makes it harder to map back from the running code to actually a source code. So these are examples where debug and release are built slightly differently. Okay, any more questions regarding build settings? Okay. Actually, these have become a lot less relevant with Swift. In Objective-C, when you want to build a library and include it in your project, you would have to change a lot of the build settings to actually link these libraries. But in Swift, the model is a lot easier. So for the biggest part, you won't have to touch a lot of these build settings. So build settings, as I said, are provided on a project and on a target level. The most important things that you'll touch is which SDK version do you want to build with? Is it iOS 8 or 9? That will also influence which devices you want to deploy to. You can basically say the minimum device type is iOS 7 or iOS 8 or iOS 9. And that means you will have to think about how to support these different devices. For example, if you want to support back to iOS 8, then you cannot use all of the APIs that were introduced in iOS 9. Or if you want to use them, then you have to use an alternative in case the device is running on iOS 8. Additionally, another setting, we're going to talk about that in the code signing section, is the provisioning profile that you use to sign the app. So these are the two most important build settings that you will deal with. Let's talk about code signing. So code signing essentially has the goal of making your apps signed by a developer and therefore making sure that when a user installs the app on a device, they know that it basically is an app that was built by an authenticated developer and was not downloaded from some third-party source from the internet. Because Apple correctly assumes that if you can download apps from anywhere, then there's a high risk that you download apps that are misbehaving and that didn't go through the app review process and maybe extract user data from the phone even though they shouldn't. That's why, in general, on an iPhone, you can install anything outside of the App Store. And to ensure that everything that lands in the App Store is actually provided by authenticated developers, there's this code signing process. If you remember one of the very first lectures, we talked a little bit about public-private key encryption. And that is, again, a process that is used for code signing your apps. So when you want to start to ship apps to the App Store, you have to create a certificate and a provisioning profile. And these essentially are wrappers around your private key. Then you download this provisioning profile and certificate, and you have a private key in your keychain. Now, when you build an app and you want to submit it to the App Store, the process that happens is you take that app, you generate a hash from that app, then that is code signed with the private key. And this all is packaged up, your app, the signature that is signed with the private key, the certificate that contains the public key, and the provisioning profile. I'm going to talk about that more. All of that gets contained into one package and sent to the App Store. And then the App Store will validate that the App Store has a public key that matches this private key by verifying the signature. And thereby the App Store will know that you, with your Apple ID, have actually signed the app. So that is just securing that the app is signed at the point in time where you submit it to the App Store and that you are actually an authenticated developer. So on the other side, the verification takes a signature and takes the public key that Apple knows belongs to your account because you created it in your developer portal, and then it decrypts it. And it ensures that the hash that it generates from the app and the hash that it generates by decrypting the signature is the same, and if that is the same, then we know that the signature was valid. So again, by using public-private key encryption, we can ensure that the owner of the private key actually has signed this app. So what does it do? It firstly ensures the identity of the developer of the application. That's important, so Apple knows who submitted this app. But it also ensures the content of the application. Because we take the hash of the application, we know that no one has changed the content after it has been submitted to the App Store. Because if someone had changed the content, then the hash that we generate from the app content would be different. So this makes sure that no one intercepts the app package and maybe injects some malicious code that, for example, logs all user input and sends it to some private server. So for any hackers that would try to integrate any kind of malicious software into your app, it would be detected in this step that it happened. Is that clear why? Cool. So it ensures both integrity of the app and identity of the developer. Just an interesting side note. If you looked into this code signing process a little bit before, then you see that the certificate and the provisioning profile have an expiration date. They usually only last for a year. But when you ship something to the App Store, you can actually leave it on there for 5 or 6 or how long, basically as long as you want, without that it expires. That is the case because Apple re-signs your app before they submit it to the App Store. So all the users that download your app actually download it with a certificate that is provided by Apple that never expires. And Apple basically only uses your private code signing infrastructure for the process to submitting it to Apple. Once Apple has the app, it re-signs it and then sends it to the App Store. That's why even though your certificate expires, it will never expire on the App Store and you don't have to update the app every year. So terms, to clarify them, certificate is basically a combination of the public key and identifying information of you as a developer. That means your name, your email address. That's very similar to the certificate that I talked about when we talked about SSL encryption. So the same certificate that would contain information about the company that is hosting the website, here it's about the developer that is building the app. The provisioning profile is a combination of the certificate. It also contains a list of viable devices. So if you're not submitting to the App Store, but you're actually building a test build, and you want to submit to some of your testers, then the devices that are eligible for installing that app are part of the provisioning profile. And lastly, the provisioning profile contains entitlements. And that's the last step I'm going to talk about. But these entitlements define what an app is allowed to do and which services it is allowed to use. So for example, if it's allowed to use location services, or if it's allowed to use keychain services. So you can actually take a look inside of the keychain at your certificate to see the information that is stored in there. And then you'll see that there's some identifying information about you as a developer, including expiration date. So the entitlements, I touched on this briefly. Inside of your app, inside of the project settings, you can define different entitlements that allow your app to use different services that Apple provides. Some of them, for example, are Apple Pay, Passbook, using the Game Center, or using access to the Maps API and location services. Basically, Apple here also wants to make sure that you have to define upfront which service you want to use so that the user they can basically verify that as part of the application submission process. On Android, it's a little bit different. There, that is conveyed to the user. So whenever a user downloads an app, they have to define if the app is actually allowed to use the keychain, if it's allowed to use location services, and so on. On iOS, Apple does that for you by basically verifying that the app only uses the stuff that is necessary, and verifying that as part of the submission process, and then just letting the user download the app. As part of that, they basically want you to define upfront which services you want to use, and you do that both in the project side, but also as part of your provisioning profile. And then you will only be successfully able to upload an app if the things you set up in the project here match the ones you defined inside of the provisioning profile. So we define the privileges, and they have to match the ones that you set up in the developer center. So if you say you want to use maps, you have to do that both in the provisioning profile and in the project settings. So to summarize code signing, because it's a fairly complex topic, we have entitlements. They define what app is allowed to do, and that is also part of the provisioning profile. The provisioning profile also specifies which certificates can be used to sign your app. And then lastly, you code sign the app with that certificate using the private key that is contained inside of it to ensure that you are actually the developer submitting the app to Apple and verify the content, and also verify the content of that app by taking a hash of the app and ensuring that the content landing on Apple's side is exactly the same that has been signed on your device. Last, we have an Info.plist. Some of you, if you've done iOS development, stumbled upon that as well. That is basically all the target-specific settings that are not relevant for the build process. So here we don't talk about build settings, but we talk about relevant information for the finalized product, so that lands on the device of the user. These are things like the product version, the product name, or the storyboard entry file. Usually you don't touch it too much either, but if you want to change the product version, you do that inside of your project settings, but it actually happens inside of the Info.plist. So that's just another piece of the whole basically infrastructure that allows you to set different build settings and target settings. Are there any questions around this? Code signing, project settings, target schemes? So I hope I was able to give you a rough overview. These slides should help you refer back to getting the high-level concepts. And for each of these topics, you can read a lot of additional resources that are linked. But that high-level overview should help you understand different issues and resolving them probably more or less self-sufficiently. Thank you.